Black holes are some of the most fascinating objects in the universe. And while they may seem like a pretty terrifying concept, they're actually incredibly useful for us humans if we can figure out how to use them. What if we could harness the power of a black hole? Would that be possible? How much energy could it generate? Let's find out. If you want to use a black hole for energy, you've got a few different options, but none of them are exactly easy. For starters, there's the accretion disk. This is the material surrounding a black hole, which spirals inward towards the event horizon, the point of no return. As this material gets closer and closer to the black hole, it speeds up and heats up dramatically. It's so hot that it glows with an otherworldly light, which is why these disks are sometimes called donuts of doom or fiery rings of death. But don't let the doomsday names fool you. Accretion disks are also one of the best ways to get energy from a black hole. The tricky part is getting close enough to siphon off some of that energy without falling into the black hole yourself. In 2021, researchers at Penn State used computer simulations to study how a black hole would interact with a cloud of superheated gas. The idea was to see if it was possible to extract energy from the black hole by poking it with a laser. They found that by focusing the laser just outside the event horizon, they could draw material from the accretion disk and heat it up even more, releasing huge amounts of energy. While this sounds pretty promising, it's not without its risks. If the laser isn't focused correctly, it could release too much energy, causing a massive explosion that blasts everything to bits. So maybe start small before going all out. But what if you want to get a little closer to the black hole? Some researchers have suggested that we could use the ergosphere to harvest energy. The ergosphere is a region around a rotating black hole where space itself is dragged in the same direction as the black hole's rotation. This means that anything that enters the ergosphere will be carried along with it towards the event horizon. That includes light, which means that once something enters the ergosphere, it can never escape. This creates a sort of barrier around the black hole that prevents anything from leaving, including energy. But it's possible to extract this energy by taking advantage of the drag created by the ergosphere. By placing a detector just outside the ergosphere and then allowing the black hole to drag it inwards, we could collect energy as the detector is carried towards the event horizon. Of course, we would need to be very careful to make sure that the detector doesn't fall into the black hole itself. But that's always true when dealing with black holes, isn't it? But there's another option, one that involves getting even closer to the black hole than the ergosphere. To understand how this works, we need to talk about something called spaghettification. As an object approaches a black hole, the gravitational pull becomes stronger and stronger. This can stretch the object out like spaghetti, hence the name. Spaghettification happens because the gravity on one side of the object is stronger than the gravity on the other side. The difference in gravity causes a stretching force that pulls the object into a long, thin shape. But this stretching force can also be used to generate energy. In 2017, researchers at the University of Copenhagen proposed a way to extract energy from a black hole by dropping a special device called a symmetric wormhole into it. The symmetric wormhole is a type of hypothetical wormhole that has a very particular shape. It's designed in such a way that as it falls towards the black hole, it will be stretched out by the gravitational force. This stretching will cause the wormhole to open up, creating a tunnel between two points very far apart. The energy released by the opening wormhole can then be used to generate power. Now, this is just a theoretical idea at the moment, but it is an interesting one that could potentially lead to a new way of harnessing the power of black holes. We haven't talked about this yet, but one of the biggest problems with trying to use a black hole for energy is that they'd be pretty hard to get close to in the first place. I mean, they are surrounded by a region of space called the event horizon, which is the point of no return. Once something crosses the event horizon, it can never come back out, not even light. This makes it really difficult to study black holes up close because we can only observe things that come from beyond the event horizon. And that's not easy to do, but what if we had a way to see inside the event horizon? A team of researchers from the Institute for Advanced Study in Princeton, New Jersey, and the HTAI in Göttingen, Germany, have proposed a way to peer into a black hole by sending in a swarm of tiny detectors. The detectors would be designed to measure the gravitational waves emitted by the black hole as it has formed. Gravitational waves are ripples in the fabric of spacetime that travel at the speed of light. They're produced by the acceleration of massive objects, such as black holes. By measuring the gravitational waves coming from a black hole, we could learn more about what's happening inside. The detectors would be sent in one at a time, each carrying a small amount of energy. As each detector approaches the event horizon, it would slow down and eventually disappear from view. But its signal would continue to be picked up by the other detectors. By analyzing the signals from the various detectors, we could build up a picture of what's happening inside the black hole. This could give us valuable insight into the nature of these mysterious objects and potentially help us develop new ways to harness their power. Of course, actually carrying out this plan would be easier said than done. Sending a swarm of detectors into a black hole is a risky business, and it's not clear that we have the technology to do it anytime soon. But it's an exciting idea that could potentially revolutionize our understanding of the universe. So there you have it. There are a few different ways that we could theoretically harness the energy of a black hole, but none of them are easy. We may never be able to use black holes for energy, but the fact that we can even consider this as a possibility is a testament to the incredible power of these objects. Black holes are one of the most fascinating and mysterious phenomena in the universe, and we've only begun to scratch the surface of their potential. Who knows what we'll discover next? It takes a lot of energy to power our world, whether it's electricity, gasoline, or even good old-fashioned elbow grease. But where does all this energy come from? The answer is simple: nuclear power plants. Nuclear power plants use the process of nuclear fission to generate electricity. Fission is when a large atom like uranium is split into smaller atoms, releasing a tremendous amount of energy in the process. This energy is used to heat water, which creates steam, which drives turbines, which generate electricity. But nuclear power plants aren't without their risks. The biggest concern is what to do with the radioactive waste that is left over after the uranium has been used. Nuclear waste is dangerous and it stays radioactive for thousands of years. So it needs to be stored properly to prevent any leaks or accidents. If you enjoyed this video, please leave a like and subscribe for more updates on black holes and other amazing space discoveries. And if you have any thoughts or ideas about how else we might be able to harness the power of black holes, please share them below. Who knows, maybe one day your idea will become a reality. Until then, keep looking up.